Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about what is page replacement algorithm is doing in operating system. Basically, if you want to know much about this page, you need to refer my previous video where I have explained you what is paging, what is page fault and etc. So now here this page replacement algorithm works when there is an issue like CPU is requesting a string and it is not found in the page, that is directly have a interlink with the primary memory location, and this page will send a trap message to operating system will communicate that to the secondary memory, and that will be retrieved from secondary memory to the primary memory. When it is retrieving from secondary to primary, now the algorithm works when the primary memory is full, right? Because it is already filled with number of strings which is there and which is staying there for a longer period of time, shorter period of time, or else in between these two. So which particular frame has to be replaced? So actually this page replacement algorithm is a technique which is used in operating system, which is used to manage memory effectively when the virtual memory is full, right? So when the virtual memory is full, we are going to check that based on this particular algorithm. Let me get into the topic directly. So what is this first in first out actually works, and what is this LRU stands for, and what is this optimal is doing in this page replacement algorithm? One by one I will explain you in detail about how this algorithm is actually working more effectively in replacing this when the virtual memory is full, and how does it replace, right? So basically here the first in first out algorithm is actually working. It's the simplest page replacement algorithm. In this algorithm, the operating system keeps tracking on all the pages in the memory based on the queue, right? And the oldest page is in the front of the queue will be replaced. So that is why I've written here, replaces the page that has been in the memory for a longest time, right? So you can see that these are all the strings which is requested by the CPU. This is a page, that is a string, it's a frame, and this frame has only 3 frames, right? So for example, this is frame number 1, frame number 2, and frame number 3. Okay, so now you can see that all these frames is initially made by purpose, it has been made empty, right? Now these all the strings in queue which is requested by the CPU. Now this particular requested string which is there in the memory or not, we are going to check it. Now the first requested made by the CPU is 7. Initially I told you these particular frames are empty. So when CPU is requested, this 7 is not available in this frame. So it is a miss, right? When it is not there, then it is a miss. When the requested string is already there inside a frame, then it is a hit. We are going to check based on the hit and miss case, and we are going to predict which algorithm performs well in operating system, that is page replacement algorithm. Right, get into the topic directly. Now the first requested made by the CPU is 7. Now the 7 is not in the frame, so let's bring this 7 inside the frame. I told you it is, if it is not there, then it is a miss, right? So again 7 is already there in frame number 1, and see 0 is requested by CPU, 0 is not in the frame, second frame is in the queue, it is empty, so I am bringing this 0 into it. Again it is a miss because the requested string is not available in the frame. And the third request is made by CPU is 1. 7 is already there, 0 is already there, so only one particular frame is empty here, so 1 is brought into that particular frame. Now this is also a miss, right? Now the frame is full. I told you already this virtual memory is full now. Now when the virtual memory is full, that is a primary location, and the next keep on CPU is requesting 203042303120. So many requests are there by the CPU. Now the CPU is requesting, and this particular page replacement algorithm, how effectively it is changing it, how effectively it works. Now I am going to do some identification by using this sketch, that is which particular string has been adopted, staying inside the frame for a longest period of time. So according to this, 7 is staying here for a longest period of time, second is 0, third is 1, right? Now the 2 is requested by the CPU, Now which particular string has to be replaced? So 7 is staying here for a longest period of time. That is what this definition mentions for FIFO. Which page has been inside the memory for a longest period of time? It is 7. So 7 is automatically replaced by 2. And 0 is staying inside, 1 is staying inside. So when 2 is requested, 2 is not in the frame. So it is also a miss, right? So 2 is also a miss, right? Right. Now you will come to know what is a hit here. Now listen, 0 is requested by the CPU. Next request is 0. 0 is already there in this particular location. So the page is not missing. So 2 is already there. 0 is there. 1 is there. So 0 is requested. So 0 is a hit. I hope you understand. Whichever the string is requested is inside this frame, then it is a hit. Whichever the string is requested is not inside the frame, then it is a miss. Right. Let's see. The next part is 3. 3 has to come inside, and we are going to check the seniority here, which is which particular string is staying inside for a longest period of time. We can call this as a page also. Right. So 2 is just arrived, and 0 is staying here. And comparing to this 3 frames, 0 is staying here for a longest period of time. So 2, 0 is replaced, and 1. So 3 is called here, but it is not in the frame. So it is a miss, right? So I'm going to use this identification mark because we are going to just check the how long it has been inside this particular frame, right? So next thing is 0 is called here. Now there is no 0 available, so it is a miss. So this request has been called, but it has a miss here. So now which frame has to be replaced? 3 is just replaced. 2 is 1, 2, 3 times it is there, and 1, 2, 3, 4 times it is there. So you can check which particular frame can be replaced. 1 is staying here for a longest period of time. So 2, 3, 0. Right? I hope you understand. Now this next frame is requested by CPU 4. So which frame can be replaced here? You can check it. 2 is staying here for a longest period of time comparing to 3 and 0. See here. So 4, 3, 0. So 4 is recently arrived. So next thing. So again 2 is called here. 2 is not in this frame. So this is also a miss. So I missed here. So this is also a miss. So now 2 is called here. 2 is not in this frame. So 2 is actually a miss here. And which frame has to be replaced? 4 is just arrived. 3 is staying here for a longest period of time comparing to this 3 frames. So 4, 2, 0. So which frame is arrived recently? I'm going to mark it. So next thing is 3 is coming inside. Now which frame has to be replaced? So you can check it here. 4 is staying here, 2 just arrived, and 0. 0 is staying here for a longest period of time. So 4, 2, 3. So 0 has been replaced. So here also it is a miss. Here also it is a miss. So next thing is 0 is requested by the CPU. Now we are going to check which particular frame can be replaced here. Now which can be replaced here? So 4 is staying here for a longest period of time comparing to 2 and 3. So 4 will be replaced by 0. Now 2 is as usual and 3 is there. So whichever is come recently will be circled with a sketch pen for identification. Now 3 is requested. You can check it. 3 is already there inside. So that is a hit. So we are not going to replace anything now. So that we used to call it as a hit, right? So next, get into this. 0 is there. We are not replacing anything. So 3. Okay. So now we are going to check that 0 is requested here. Sorry, here it is a miss. This 3, here it is a hit. Okay. So now the same process has been, string has been repeated again because 3 is already inside. So we are not replacing anything. Now 1 is requested. So now you can check it. 0 is staying here. 3 is staying here. Which particular thing has been replaced? 2 is staying here for a longer period of time. So the identification is comparing here and we are going to check it. So 0 is as it is. 2 has been replaced by the requested frame called 1, 1 and 3. So now 1 is just arrived. Now 2 is requested by the CPU, which frame has to be replaced. You can check it very clearly. Comparing to these 3 frames, 0, 1 and 3, 3 is staying here for a longer period of time. So 0, 1 and 2. Right? Now 0 is called here. So if the 0 is called here, then you can check it. 0 is already there inside. So 0 is already inside. That means what? It is a hit. Right? So it is a hit. So here it is a miss. Here also it is a miss. Right? Now this is how this particular process works. Now we have been replacing this by using this particular algorithm. We replaced effectively, and we are going to count how many number of hits here. Right? Now we are going to check the page fault. Right? Now say for example, what is page fault? If the CPU is requested something and it is not available in that particular location, that is a page fault. It is not available in the page. So page fault is equal to how many number of miss, that is a page fault. So we can calculate here 1 2 3 4 5 6 7 8 9 10 11 12. Right, totally we have 12 page faults. Right? So again we are going to count. This is fault, that is miss. Okay, so we are going to calculate page hit. Page hit in the sense we are going to calculate how many hits are there. Number 1 and number 2. Here it is 2. Here it is 3. So totally 3 hits are there. Right? So the formula is we are going to calculate the hit ratio. Okay, so hit ratio is equal to number of hits divided by total reference, right, into 100. So this is the formula. So number of hits, how many number of hits we have? 3 number of hits. Total references, how many reference we have? Number of reference string, you can check it. So it is a 15 reference strings are there. Okay, so we are going to calculate hit ratio here. So 3 divided by total reference, that is requested by the CPU, is 15 into 100. Okay, so you can check the value. And we are going to identify the fault ratio also. How many faults are there? We have already checked. Number of page fault is equal to 12. So the fault ratio in the same formula you can apply. Instead of number of hits, number of faults has been done. So what is number of faults here? The number of faults here, it is 12 divided by the total reference. What is total reference here? 15. That into 100. Right? So this is how this particular page fault algorithm works, and this is how the FIFO is actually working. I hope you understand the video. Thank you.